every galaxy I've traveled, all you species are the same. You all think you're the center of the universe. You have no idea.
People often wonder, why is it that we haven't been visited by aliens, right? This is a thing that comes up whenever you're talking about other life inside the universe. But the answer to that could be quite straightforward. Nobody out there cares about us because we're so ill-developed. We're so young on the cosmic scene that there's nothing interesting for them to find here on planet Earth. So to me, there's a natural explanation for why there can be other life out there, and yet they don't hang out around planet Earth, just the way we don't hang around an anthill to try to have a conversation with, you know, what's going on inside that particular structure.
Nature is full of these crazy patterns called fractals. They're like these never-ending designs that repeat themselves on different scales. And get this, there's a major math theory. Yep, fractals show up in both math and nature. Math fractals are created by doing a simple equation over and over again. In nature, you can spot fractals all over the place. Lightning bolts, for example, have jagged lines that repeat themselves in smaller sections. Fractals can be tough to wrap your head around, but they're actually made up of simple shapes. Like, look at this oak tree branch. It's just a bunch of repeated Ys. And let's not forget about snowflakes. They're one of the earliest fractals ever discovered. Each snowflake has its own unique design, but they all follow the same pattern. This is how math, art, and nature are all connected.
So when you use a fractal equation and put mathematics into it and plot these fractal geometries in a computer, guess what you find? The structures that result from solving a fractal equation are replicas of things that we see in nature. And all of a sudden it says, my goodness, you can put a number into a fractional equation and create what? Mountains with clouds. All of a sudden it says, this is what nature is based on.
City I was born Let's play the chaos game inside of an equilateral triangle. Start with a dot anywhere inside the triangle. Now iteratively add a point 1/2 of the distance between the current dot's location and a uniformly randomly chosen vertex. Here are the first few iterations of the chaos game. But don't just do this a few times. Let's do this 30,000 times and see exactly what happens. The limiting shape is the famous fractal known as the Sierpinski triangle. Check out the linked video in the description to find other constructions of this awesome triangle.